Okay, and now we've reached objective 3, where we're going to actually construct or calculate these confidence intervals. So the first thing we're going to talk about is what's called the standard error. And the standard error of your p hat is going to be your estimation for the margin of error. So notice what it entails. It entails that z star multiplier, as we talked about. So that's just the multiplier to make your interval wide enough. And then this right here is going to be just like the standard deviation equation or formula that we used to find the standard deviation of the sampling distribution of p hat. Notice it has the p hat values in there, right? Because we are not given the p value. So again, what this does is it's an estimate of the standard deviation. Again, just very similar to that formula. And then again, the standard error of p estimates how much p hat typically varies from p. Again, there's those words, typically varies. And again, it's all about a width, right? It's about a variability, a width, that kind of stuff, a spread, if you will. All right, here it is. Without further ado, we are looking at the confidence interval for a population proportion p. So when your conditions are met, a C% confidence interval for p looks just like this. Boom. So it is p hat. P hat is your point estimate, plus or minus your margin of error. And as I showed you in the last slide, this is your standard error for p hat that we're going to use as the margin of error. Notice this plus or minus sign. So remember, the point estimate's right in the middle. We subtract the margin of error to get the leftmost value in our confidence interval. We add the margin of error to get the rightmost value. And again, that z star is that critical value with C% of its area between negative z star and positive z star. So again, remember that in this drawing, this is negative z star, this is positive z star, and this right in here, that's going to be your confidence level, because we're that percent confident that our value's in there. Okay, so be aware of that. All right, so let's have some fun with one of these big long problems. All right, so again, example 3, what proportion of beads are red? Dr. Gadlowski's class selected an SRS from her container of beads and got 107 red beads and 144 other beads. Calculate a 90% confidence interval for P. So let's just go over how we would have to do this problem. So the first thing you would want to do is you want to make sure your conditions are met, but they are, right? So we already met the random condition, and we already met the large counts condition in example 1. So let's go ahead and identify our p hat value again. So your p hat value is the number of red beads out of the total. Remember that 251 you get by adding those two numbers. So remember that came out to be 0.426, and that's all from example 1. Your n value is 251. Again, remember that your normal condition and your large counts condition are already met. And all of this is from example 1. Okay? So once you're here, now we need to take our confidence level and find our z star value. Now notice this is not the same confidence level from example 2. This is a different one. This is 90%. So again, all you have to do, I'll change color. To find your z star, what you're going to do is you're going to do 1 minus 0.90 divided by 2. This will give you the area of the left tail, 0.05. That's the left tail area. Again, if you need to draw your picture, that's this area right there, 0.05. We are going to use the stats applet to find the negative z star value and then interpret it as a positive z star value to use in our equation. Okay, so I'm going to go away from this. We're going to finish everything on the stats applet page and the calculator, because calculating this is important as well. Okay, so let's go to our stats applet. Let's type in 0.05 for our area. Stats applet, again, calculate a value. My left tail area is now 0.05. And there's our negative z star value right here. Negative 1.645. So our z star value is positive 1.645. And here is going to be our confidence interval. It's going to be our point estimate p hat, 0.426. plus or minus z star 1.645. And then in parentheses, you're going to put your p hat value, 0.426, times 1 minus your p hat value, 1 minus 0.426, all over your sample size of 251. And that whole thing gets put in a square root. And that is what you have to then evaluate to find your confidence interval. Now, here is how I teach it. So please pay very close attention. I leave this and this alone, 0.426 plus or minus, and I'm going to type this into the graphing calculator as it looks. So I'm going to take a picture. I would suggest use Desmos graphing calculator because it does a great job of letting you type it in just like that. So when I go there, I'm going to type in someday. There we go. 1.645 square root fraction bar. Okay, 0.426 times 1 minus 0.426, close parenthesis, all over 251. Notice that the square root encompasses the 251. I know that some of you are going to do this. You're going to do it just like this. Watch, square root of 0.426 times 1 minus 0.426. And what's going to happen is, probably not that, but the 251, notice it's not going to be in the square root, right? The square root's only on top. More thoughtfully, I thought it would be like this, 1.645 times. So like that, right? There's a big difference, right? Do you see the difference? This square root goes under, whereas this one does not. That's wrong. The second one's wrong. The first one is correct. Okay, and when you do this, our point estimate was 0.426. So at least cut it off at the same number of decimals. You could go one more. I'll just go 3. So 0.51. That's fine. The 3 does not change the 1. So plus or minus 0.051. This is our point estimate. This is our margin of error. And now we're going to actually subtract and add these numbers. So watch. 0.426, 0.426 minus 0.051, and 0.426 plus 0.051. And these are the two numbers that make my confidence interval. So my confidence interval for this proportion of red beads is somewhere between 0.375 to 0.477. So what I am saying is that in this population of red beads that Dr. Galuski's class pulled from, I am thinking that the actual true population proportion of red beads is somewhere between 37.5 and 47.7%. And I am 90% confident that that is true, that it will actually capture the true value. Okay, so hopefully that went okay for you, and you're able to do some problems. Again, this section is very much related to the next section, section 7.4. In this section, the problems are kind of broken down. Now, in your homework, I'm going to put them together. And then in 7.4, it's just taking these problems and putting them into more context. And you'll see that tomorrow. All right, thanks for watching. Good luck on the homework.